Here's another way of looking at a conjunction. This is an understood and. Something less than an x expression less than something. All right? If we read it from the x expression to here and from the x expression to here, x minus 2 is greater than negative 2, x minus 2 is less than or equal to 4. This and this. All right? So it's an understood and happening here. So when you see that picture, that's also an and statement. We don't want this to be x minus 2, we want this to be x. So what I want to do is I want to add 2 to make that minus 2 go away. So I want to do plus 2 here. This is a 3-piece inequality. If I change one of the pieces, I change all the pieces the same way. So plus 2 goes here and plus 2 goes here. Okay, but again, you want x in the middle. So anything that isn't x needs to be dealt with. Minus 2 plus 2 cancels, leaving x. This stays less than or equal to. Negative 2 plus 2 is 0. 4 plus 2 is 6. We do want to get numerical values on either side. Where these 2's cancel, leaving me x plus 0, which is just x. These 2's also cancel. I actually want to write that 0 down because I don't want to look at a blank space. Blank is less than x. I don't know what that means. So make sure that 0 shows up. The numbers show up on either side. If 0 happens to be one of those numbers, write it down. All right. So again, if I'm looking at this in conjunction world, this is what this right here means. It has less thans, and that messes some people up. So let me just clarify this so there's no confusion. If I read it from x to the number, x is greater than 0, is what that says. Even though it's a less than symbol, if I read it from x to the number, x is greater, see it's opening up to x is greater than 0. And this part here is x is less than or equal to 6, and there's that magical word and in between them. Okay? This is a much more concise and elegant way of writing it, but that's what it truly means. And again, that's what you have to understand is what it truly means. All right. Now this time you'll notice the domain is a set of real numbers. So now instead of putting dot, 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 I need to worry about open and closed circles on the endpoints, and I need to shade things. All right. So if I'm considering that x is greater than 0 starts here, open circle, and goes off this direction, right? Notice I didn't go very far. I just want to get an idea of which way I'm going. Okay, so if I was to graph this part only, I should probably do it in black since it's black, right? If I was just to do that part only, it would go like this and go all the way over to here, right? If I'm doing just the x is less than or equal to 6, less than or equal to gets me a closed circle at 6, right? It goes which direction? Left. To the left, goes that way, right? So the black one's going from 0 to the right, the green one's going from 6 to the left, and the part where they're both true is going to be in between them. All right, so the answer to this thing is simply shade all the way to here, or shade all the way to, oops, different color, shade all the way to there. Whenever you have this type of picture, small number less than x less than big number, open or closed circle here, open or closed circle here, shade in between. If this said integers instead of reals, only graph the integers to make it true. 0 isn't, graph 1, 2, 3, 4, 5, and 6, that's it. Alright? And again, that's how you graph these conjunctions. Both of those, either it's two inequalities with the word and in between, small number less than x less than big number. One of those two structures, both of those create just a finite set if it's integers, or a beginning and an ending point if it's reals. Shading in between.